Imagine pushing a heavily loaded bicycle up one of the steep hills in Kabale. Your legs are burning, your breathing is heavy, and every single pedal stroke takes maximum physical effort. Then, with a quick click of the gears, the chain snaps into a new position. Suddenly, the pedaling gets easier, and the strain on your body disappears. The hill hasn't flattened out, and you certainly didn't grow stronger in the last 3 seconds. So why does the exact same climb suddenly feel so much easier to manage? To answer that, we have to look at what a machine actually is. In technology and design, a machine is any device that helps us do work more easily by changing the size or the direction of a force. The everyday bicycle is a highly efficient mechanical system, a clever arrangement of basic parts that coordinates the laws of physics to your advantage. If we take that bicycle out of the real world and break it apart into its core components, we can see exactly how it does this. Before any of these moving parts can actually function, they have to be held securely in place. That is the job of fasteners. Whether they are permanent, like rivets and welding, or temporary, like the nuts, bolts, and screws you see on a bike frame, fasteners are the hardware components that prevent the whole arrangement from falling apart under heavy stress. This diagram shows a bicycle brake handle, which is a perfect example of a lever. To understand it, look at the pivot point. We call that the fulcrum. When you squeeze the handle, you are providing the effort. That force moves the brake cable, which is the load. Watch how this works in motion. Pressing down on the rigid bar pivots that central point, multiplying your force to pull the heavy cable. This illustration shows a village borehole water pump. The long handle is the lever, pivoting on a central fulcrum to lift heavy water from deep underground. A farmer digging with a hoe or a builder lifting sand in a wheelbarrow are all using these same parts in different ways. By adjusting where the fulcrum is placed, a lever multiplies the force you put into it, making heavy loads feel much lighter to lift or move. While a bicycle uses levers for its brakes and pedals, it doesn't use every type of simple machine. For instance, pulleys are rarely found on a bike, but they are absolutely vital out in the community. Look at this worker at a construction site in Kampala. They need to lift heavy cement bricks up to the second floor. Instead of carrying them up the stairs, they use a rope strung over a single grooved wheel, a pulley. A single fixed pulley like this changes the direction of the force. The worker can pull downwards on the rope, using gravity and their own body weight to do the hard work, rather than straining their back to lift the heavy bucket up into the air. Returning to our bicycle, this vector diagram shows the drive mechanism, the front pedal, the chain, and the rear wheel. This system relies on gears, or sprockets, which are simply toothed wheels that pass a turning movement from one part of the machine to another. As the animation plays, you can see how the chain connects the large driving gear to the smaller driven gear. Because it has fewer teeth, one slow, full turn of the large front gear results in multiple fast turns of the small rear gear. This trick for multiplying speed is what allows a rider to travel long distances with very few pedal strokes. It is the same principle that powers local machines like sugarcane crushers and pasho mills. At this point, it is easy to assume that these tools are doing the work for us, reducing the total energy we have to spend. But in physics, you cannot cheat the budget. This balanced scale shows how work actually functions. In scientific terms, work equals the amount of force you apply, multiplied by the distance over which you apply it. When you use a simple machine, watch what happens to the scale. The machine allows you to apply a smaller, easier force. But to keep the scale balanced, you must apply that smaller force over a much longer distance. Simple machines just reorganize the work into smaller, more manageable installments that our human bodies can comfortably handle. When we take those individual fasteners, levers, and gears and piece them back together, we move from simple machines to a mechanical system. A simple machine is a single basic device, like a lever. A mechanical system is a collection of these machines all functioning together as a single unit. This is how our cyclist in Kabale makes it to the top. The pedals act as levers to drive the gears. The chain transfers the motion to the back wheel, and the fasteners hold it all together. Next time you walk through your community, look for these logical systems. You will see them in a tailor's scissors, in a wheelbarrow at a building site, and in the gears turning inside a pasho mill. Mastering how these basic components work allows you to design, repair, and invent new machines that solve physical problems for everyone in Uganda.